Hi all. This is going to be the first video, which is going to be our introduction video to the topic of conic sections. Now we would just begin by just explaining what a conic section actually is, and that there are different types of conic sections, and we're going to focus specifically on just a couple of them, the ellipse and the parabola here. To start with, conic sections is part of what's known as plane geometry in drawing. So plane geometry basically means flat. When you think of a plane surface, you're talking about a flat surface. And so what we're dealing with here aren't 3D shapes, but actually just two-dimensional objects. Really, that's what it breaks down to. Um, but even though we're dealing with 2D shapes, they can actually derive from a 3D concept. So the shapes that we're going to be dealing with here all are sections of a cone. So here we can see a cone like so. And if we take a horizontal section, so literally like a level of water cutting straight across our cone, the shape we're going to get is going to be a circular shape. So a circle is said to be a conic section. Depending on the angle of which we cut the object, we're going to get a different type of shape. So for example, if we cut our cone here at an angle that's less than the angle of the edge of our cone, the shape we're going to get here is an ellipse. If we cut it at an angle that's equal to, so if this was say here 60 degrees, if we cut it at an angle of 60 degrees, the shape we get is a parabola. If we cut it at an angle greater than the side of our cone, so again going with the example of 60, if we cut it at say maybe 70 degrees, well we get what's known as a hyperbola. And for the junior cert, we focus specifically on the three ones. So properties relating to the circle, properties relating to the ellipse, and properties relating to the parabola. The hyperbola here will be a leaving cert topic. So with that then, we'll just have a look at the ellipse, which is the one we're going to focus on for the next number of weeks. So the ellipse is basically gotten by, as we said already, slicing a cone at an angle. So you can see, and the angle must be less than whatever side the edge of our cone is here. So our extreme generator here, if he's at 70 degrees, any angle less than 70 will result in an elliptical shape here. That if this was an angle of 80, any angle less than 80 would give us an elliptical shape like that. The same thing applies when it comes to a cylinder, although for a cylinder any angle will work as long as it's not horizontal, which would obviously give us a circle, or vertical, which will give us a rectangle. So our section there, either of a cone or of a cylinder, will result in our elliptical shape. So for the next thing then, looking specifically at that, um, a circle like that and an ellipse are very, very closely related. And in fact, an awful lot of the properties that we apply to the circle can also apply to the ellipse. But a circle is like that, look, is basically looking straight at the shape. If we saw a circle from an angle, the shape we're going to see is going to be an elliptical shape. And some people will call that an oval shape. And as teachers yourself, it's probably useful to know that, say, from the previous knowledge, your own students will have encountered ellipses, but they may not know them as ellipses. They might call them ovals. So an oval is just kind of a, I suppose, a primary school name for your elliptical shape. The ellipse is used for all over the place really because they're so straightforward to draw. You often see it for tables, and they're very useful for tables because it allows quite a large amount of space, but you can get easy access to the center as opposed to having a circular table where you'd have a lot of dead space in the middle, like so. You can see it in logo design. In fact, an awful lot of the exercises we would do would be based around logos. Generally speaking, kind of curved shapes of that gives a friendlier design for the logo as opposed to harsh, sharp edges. Again, a kind of a console table there like that. And you see it from parks and in a lot of Georgian architecture over door frames, bridges. So it really, really is quite a common shape that we'll see around the place. There's plenty, plenty of examples. And particularly for the new junior cycle graphics syllabus, one of the things you want to do is get your own students to explore examples of the geometry and maybe why was it used here, what was it relating to. So it's a nice activity for your own students to find as many examples and then come in and present them, because that's feeding into, particularly into their first CBA, their first classroom-based assessment, where it's basically about exploring and demonstrating and communicating the actual geometry. So there's our example like that. Other examples in nature are, say, the orbit of all the planets around the Earth. You mean satellites going around the Earth as well will all take an elliptical orbit. So just let's start off by just looking at the parts of the ellipse, and then we can do our first example of how to go about drawing it. So the ellipse itself, if we were taking the widest portion going from left to right here, that's what's known as the major axis, and it's basically dividing our ellipse directly in half, so the top half and the bottom half. That's the major axis. We also then, if we go from top to bottom, joining the two shortest portions of our ellipse, we'll get the minor axis. And the two will cross in the dead center of our elliptical shape. We also have what are known as focal points. A focal point basically is essentially acting as the center for our ellipse. But unlike, say, the center of a circle, we have two focal points, and both of which are placed on the major axis here like that. And the way we find our focal points is we measure half the distance of the major axis and we swing that from the top of the minor. Same way from the far side there. So that's one on one side and the same on the far side then, two focal points. And the position of our focal points here will determine the curvature of our ellipse. So for example, if these were to move further away, the ellipse here would just be longer and narrower. If we were to move the two focal points closer to the center here like that, the ellipse will start to get more and more circular in nature until eventually if they meet and the center point, well, we actually now have a center of a circle. So that's where I suppose the relationship between the circle and the ellipse starts. We'll come back on focal points and we'll talk specifically about where we actually derive or get our focal points from and how they relate to, I suppose, what makes up the curve itself. But for the moment, that's just enough to kind of give us an overview of what they are. The vertex then is the point, the outside points. So this would be our vertex here and our vertex here along the major axis. And the plural of vertex is vertices. So vertex 1, vertex 2. The major circle then, or sometimes known as the major auxiliary circle, is basically a circle that we get where we have the radius of the major axis. So that is the major auxiliary circle, like so. Then we can take the exact same thing using the center of our minor axis as the radius. That gives us the minor auxiliary circle. So minor auxiliary circle, major auxiliary circle. And that's really, I suppose, the main kind of terms that we use when it comes to our ellipse. And again, it's important that you're using the correct terminology. And when you're referring to things, you're referring to them by their correct name. So, well, major circle and minor circle. Um, so we'll first of all have a look at just how to go about drawing the ellipse. There's a multiple different ways that we use to draw them. We can use the rectangle method, we can use the concentric circles, we can use the trammel method, we can use the pin and string method, and they're only literally just a few examples. There's other methods, direct traces methods, all sorts of different methods to draw your ellipse. But we're going to start off with the most commonly used one, which is the concentric circles method. And basically, in order to use the concentric circles method, we must know the overall width and the overall height, so the major and the minor axis of our ellipse. So we're going to just take this example here of 80 mil overall minor axis and 120 major axis. So we can just draw in our major and minor axis. So we can see just 80 like so. Our major axis then 120. And what we'll do is we'll just mark off our 60 one side and 60 the other side. So with that then we'll draw in our minor auxiliary circle like so, just put point of our compass on the center and we set it to the radius of our minor axis. Then we do the exact same thing with our major auxiliary circle. So again, center point on the center and set to, in this case, 60, half the major axis. So now we have our two circles like that. And what we're going to do is we're going to break up the each of these circles here just using our 60-30 set square. And the only reason we use 60-30 is because it gives us a nice even spread of points. So 30 degrees there, 30 degrees like so. And then we just switch the set square and we go and do 60-30 from the opposite sides. So obviously you'll be using your t-square and your set squares for this. So what do we already know about our ellipse? Well, we know this is a point here on the left, this is our point on the right, this is our point here on the top, this is our point on the bottom. Now to find the remaining points on our curve, what we do is we use these lines here which are known as ordinates, and where each of these ordinates hits the major auxiliary circle and the minor auxiliary circle, we're going to draw two lines and we're going to join them together and locate our points. And the way it works is that when the ordinate hits the major auxiliary circle, we draw a line parallel to the minor axis. So it's major and minor. So here we can see, if we just take an example, So there is our set square like that. There's our ordinate where it hits the major auxiliary circle. So you can see we're going to go parallel with the minor axis. Same way from the top point here. And this is the beauty about your 60-30. You can do the two at the, the top one, the bottom one at the same time. And we can do the exact same thing for each of our ordinates like so. We don't need to do for the middle because that is our point there and there. And we can see there is our, like that. So yeah, and you should well do all the vertical ones here all at the one time rather than going back and forth with your set squares. So like that, we've gone parallel to the minor axis from the top of the major auxiliary circle. Now we're going to go parallel to the major axis from where the same ordinate hits the minor auxiliary circle. So again, keeping with that major and minor approach. So you can see there we have our point where our ordinate hits the minor auxiliary circle. So we're going to draw a line parallel to the major axis. So we can get the 2 points there, and that where they cross our original lines are going to give us our points on our ellipse. So we'll just do all the horizontal lines at the one time, and there is our points. So that gives 1, 2, 3, and you're just simply going to freehand in the ellipse itself. So there's our points located on the curve, and we can just go and draw them all in like so. So there's their point. And one thing to note actually is that we've gone 60-30 with these ordinates here. You don't necessarily have to go and use 60-30. You could use absolutely any ordinate you wanted. Like say if I wanted another point a little bit closer to here, I could just go and take another ordinate and then that would give me, that point there. So if you find you're drawing quite a large ellipse, you're not just stuck with the 12 kind of lines here like that. You can do as many as you want. It works for every single one of them. But that is our concentric circles method for drawing in our ellipse. And the next videos we'll go through some of the sample exercises for that, and then we'll look at some of the other methods and we'll do some sample exercises for those as well. But that's our concentric circles method.